Okay, start.
Okay. So good morning, everyone. I want to start by talking about our next milestone that we've decided on and where we are in terms of the milestone's progress. And there was one issue that we were discussing last week, and we wanted to go back, do some research, come back with more data to continue the discussion. I want to continue the discussion now that we've done the research. So let's start with the milestone. So we wanted to show a demo. The demo will include the simplest cozy use case, which is provisioning a greenfield bucket, provisioning bucket access for that greenfield bucket, and then providing that bucket into a pod for a workload. So one of the properties I wanted for this demo was that the quality of code and the quality of demo would be as close to production quality as possible at this stage. What I mean by that is we want to follow the best coding practices and have unit tests, integration tests in place before we show the demo, so that when we do show the demo, we know that this feature is actually in place and people can start trying it out and using it. So in terms of the progress for this demo, as of this is as of last week, I've got the dates mixed up, but as of last week, we're still working on the sample provisioner, and we were implementing the bucket access create credentials part for our sample provisioner, and this week we've finished that. Another thing is we've added more unit tests for the sidecar controller, and we are continuing to add more unit tests on the other components as well. Finally, the other effort that's been going on is we've been migrating our code from the temporary repository that we were using to the official repos now that they're in place. So we created one new official repo called Container Object Storage Interface -API because we needed a location to put the API spec or the API definition, since it'll be shared between the three components. So for those who are looking to go through the code or would like to subscribe to updates in terms of the coding progress, these are the repo names. They all fall under the Kubernetes-SIG's GitHub organization. All right, moving on to the next step. So the issue we were discussing last week was about credential minting.
Sorry, could you go back to the last slide real quick? I just wanted to. Okay, cool. Thank you.
So let's go into credential minting. So when we provision access for a bucket, we do it in two ways. We either mint credentials, which are access key and secret key or some sort of token, and the second way is we provision access for a service account that the workload is associated with. In this case, I'm only talking about the minting credentials part, where we create access key and secret key or a token so that the workload can authenticate itself to the backend. There are a few scenarios here. If there is a workload that requests a single bucket, what happens is we can mint the credentials and we can put the credentials into the pod. Here I've taken the example of S3, and I've given the path for the credentials as home/ubuntu/.aws/credentials. Now, one of the things we said about this was the provisioner knows the name of the file. So the provisioner would return credentials, and the user knows the home directory. So the pod spec would say, this is the home directory, which is home/ubuntu /.aws, because that's where they would want the credentials file to reside. And we would concatenate the two strings to get the final path where we would put the credentials file. So this is the simple use case where one pod requires one credential. Now, let's say a pod.
Hold on. The other assumption is where all the credentials can fit in one file, right? Like we suspect that there's situations where like one file isn't going to cut it.
Yeah, I'm getting to that.
Okay.
Yeah, that happens when there are multiple buckets.
Well, no, on Monday we discussed the case of like, what if you need to specify a CA cert? Like that doesn't go in the credentials file. That would go.
Yeah, that too. Yeah, I was going to bring that up in the context of multiple buckets and bucket discovery, but yes. So even if you have this credential file, there needs to be a mechanism to let the workload know the name of the bucket. Because when the workload starts, there is no guarantee that the bucket will already exist. And if the bucket doesn't already exist and Cozy is creating it, the name of the bucket is not known upfront. It can't possibly specify in the pod spec.
I thought that was one of the guarantees that we did make, was that we would inhibit the bucket from starting until the bucket was, I mean, the pod from starting until the bucket was there.
That is true, but how do we let the pod know? So the pod object gets created before the bucket can get created. So that much is possible.
The pod gets created and the bucket request gets created, but the bucket object doesn't get created until you actually know the name of the bucket. Therefore, the bucket request doesn't bind. If the bucket request is unbound, the pod can't start. So the pod is just sitting there waiting for its bucket request to bind. The moment the bucket request binds, then it starts up, and at that point, you know you have the bucket name, because you couldn't have bound it if you didn't.
Right. I'm saying it can't be specified in the pod spec upfront. It needs to be discovered by the workload somehow.
Yeah. Okay.
That's what I meant by, yeah, bucket discovery. So we need a mechanism to let the workload know that this is the name of the bucket.
Oh, and that's not in that credentials file?
The credentials file for AWS, for instance, only holds access key and secret key.
Okay, yeah. So more reasons why we need to have multiple bits of information that might not all be in the same file. Okay.
So going to the next scenario, we'll get to the bucket discovery and certs. The next scenario is if you have multiple buckets with multiple providers. In this case, you can have each of the providers have their own default paths. So for something like for AWS, it is .aws/credentials. And for Google Cloud, it's .gcloud/config.json. So in this case, there is no conflict of paths, and each bucket, the client for each of the providers would look for their individual configurations or credential information in their default paths, and we expect it to just work. Now, going to the next scenario is if we have two different buckets for the same provider. Now, if we were to follow the model that we'd originally discussed, one of the problems that we'll run into is if you are trying to use the default directory for the provider, then we'll end up with a conflict. You could say one of the ways to resolve this conflict is to come up with a merge strategy. But I think based on our discussion the last two meetings, and just being able to reason about it, it makes things more complicated, and it's worth exploring a simpler approach here. So there are a few problems here that kind of come up when you see this. One is we don't know which bucket's credential resides where. Other than the merge conflict, we have a few problems. Put each of the credentials in a separate path for each of the buckets, something like that.
But as you said, also the information about like the actual bucket name to be used, right?
For the name of the
the generated bucket name, for example, for greenfields.
Yeah.
So it's the same when we're looking at just the .aws credentials model. This is just not describing the entire information that we need to inject into the pod, right?
Yeah, it's giving you the creds, but not the bucket name or endpoint name or region or any of that jazz.
It's just partial, and we even chose to follow a model where every bucket access request has its own credentials, which means that it's not that we assign a single identity per pod and then use that somehow, but we kind of delegate to the pod multiple identities per every connection it needs to make. So, and AWS Credentials has a model for that. It's called profiles, but I'm not really sure most applications use it this way today. So
yeah, it has the concept of profiles. The issue with that is, how does the application know which profile is for which bucket?
It doesn't, and that's the point. I mean, I don't think the model for S3 SDK is ready for multiple credentials per multiple buckets. It can be programmed to do that, but it's not that by default it gives any model to this, like you said, bucket discovery, things like that, right?
So we're addressing that. So first, to deal with the conflict, the conflict of paths, we can put each of the buckets credentials inside a separate directory. This would address the conflict issue. Now, however,
how do you determine the name? Is it generated, or is it something the user would provide in the pod spec?
You would have to go in the pod spec, like the mount path for a PVC.
Yeah, that's what I would imagine.
So bucket discovery is still an issue. The workload still doesn't know what's the name of the bucket.
But if the workload provides a mount path for every bucket access request that it binds into it, and that bucket access request binds into, like, say, a credentials file in each of these paths. Say it's a directory, each one is a directory, and then you have a credentials in each one, and then the config in each one, and maybe even, if needed, like a JSON file for Google cloud storage and things like that, right?
And a SCA cert potentially.
Yeah, exactly.
Yeah.
But then we kind of will have to adapt some applications in this way, because they will not guess it unless you have a single, and then you just mount it to your home directory.aws, and it's it becomes
the user
compatible.
can still choose to do that. Yeah, user can still choose to do that
For a single kind of case, right?
For a single case, yes. So just like you mentioned, so we were thinking of 3 different predefined files. One for credentials. So in case of AWS, it would be called credentials, but in case of GCA, Google Cloud, it would be called config.json, and appropriate names for appropriate providers like that. We wanted to have a bunch of cert files. So in case of client TLS here, we'll need a client cert and a CA if it's self-signed.
A client cert would be part of the credentials if it was necessary.
Not in case of, say, S3. So the credentials file is pretty narrow, the way it's defined for S3.
Yeah, but S3 doesn't rely on client certs. It relies on the access key and the secret.
So there are use cases where S3 relies on client certs. So there's something called AWS Snowball. So AWS Snowball is something I've used. So what they do is if you want to transfer a lot of data from S3 to outside of S3, say a single petabyte, 1 petabyte, then you couldn't do it over the internet. You can get a maximum of a gigabit link to S3, and it takes a really long time to transfer a petabyte of data. So
Yeah,
what S3
8
does
million
is,
seconds at 1
yeah,
gigabit.
yeah, it takes days or months, I think. So anyway, so what they do is they ship a box like a suitcase, which has 4 AWS instances in it. Like it's a real, it has the same experience as you would use the AWS cloud. It's got all the bits there for orchestrating EC2 instances and creating S3 buckets, and you can connect your own 100 gigabit link, physical link from that box to your data center and transfer the data out. And this box gets shipped within the week, and you can ship it back to them. They send it with the label and everything. So
Wow, I've never heard of this. This sounds wild.
yeah, I've actually done that petabyte transfer once.
Wait
And if
till you
you're
see
using
the truck. That's something.
um, I'll quickly show you. Yeah, that's what it looks like. Yeah, this is exactly what it looks like. Oh, let me click on. Yeah.
They can fit a petabyte in that thing?
No, this one can only do 80 terabytes.
Oh,
They'll ship 12 of them. Okay, so actually it can only do 75, even though it says 80. Anyways, getting back to this. So in that case, you end up using self-signed certs, and when you do that, you'll have to provide a CA certs or client certs for something like S3. So anyways, I'm thinking this.
well,
So
hold on. We're not proposing that Cozy is compatible with this Snowball thing, are we? Because that's a really weird case.
no, I'm saying if someone were to do snowballs with Cozy, we shouldn't stop them in any way, because the main use case of Snowball is to transfer data in and out of it.
But it
So
feels like that's not really S3. That's like S3 with some special sauce sprinkled on top. And it might
I think it's a
deserve.
very valid use case because
Yeah,
someone,
but
You
like
mean client certificates? Is that the discussion?
yeah,
Or server kind of
no, the discussion
CA
is
bundle, things like that?
can we assume that the credentials file will always have something to specify certs?
well, my only assertion was if a client cert is necessary to authenticate to the server, then it's implicitly part of your credentials. And it sounds like in the case of this Snowball thing, there's a modified version of S3 that involves a client cert, and so we should conceptualize that as like a separate protocol where the client cert is part of the credential. It feels like that to me. Again, I don't know the details, and I don't know how common that is or how many other changes they've made.
I
But
don't know how much client certs are today used for microservices authentication, but I think that's the use case, right? If you actually want to limit access, right? Based on
well, it's exactly how the Google stuff works. The Google stuff is all client certs, and that the JSON file that you get with your creds basically has the certificate embedded in it, I think.
Is the client cert also used for authentication?
I believe so.
That's possible, yeah. But I always assumed they had a separate token for authentication and authorization, and the certs were simply used
It,
to ensure that.
you can have a token or a private key. I think that the JSON file has a fairly flexible format, and whatever it has, it will try to use. You're right.
Okay.
Maybe it's more common just to have a token in there, but I thought that you could embed a client cert in there, and it would just use it to authenticate you.
I think for some providers it's possible, but choosing to use TLS or not is more of a orthogonal concern.
Well, I guess my concern is like when we say like this is what S3 is, and this is what Cozy is going to give you if you ask for S3. Most people aren't expecting a client cert to show up, and most applications aren't going to just
Yep.
use a client cert.
And
that
probably
you
also
supply.
most providers will not provide it to the to
Yeah.
Cozy, right? So it will be an optional. We're suggesting something that Cozy will transfer as an optional feature. Is that?
Well,
well,
but what I'm saying is like normal
we don't.
S3 just doesn't have that, and like if there's a special flavor of S3 that does, it kind of deserves its own protocol.
It's not even related to S3. It's based on any REST. It's related to any REST, client, right?
Yeah, any HTTP client.
Yeah, I agree with Ben here. I think having it as a standalone protocol makes sense. We definitely should support it, but no need to kind of muddy the standard S3.
But
Hold on a
would-
second. So, sorry, go ahead. Someone was speaking.
Yeah, sorry. This would basically impact every single on-premises S3 installation where there is the TLS cert of the S3 endpoint is not signed by one of the well-known certificates that may be part of the container that is running in the pod and running the S3 client application.
So this is a second case. So I thought that was the discussion about the CA bundles.
Yes, the server cert is something that you're going to need to supply for exactly that case where it's not a public cloud, it's a private thing. The CA cert needs to be passed down so that the client knows that they can trust it. But I think almost any client in the world would know how to deal with that. But this like you have to use a specific client cert. I would imagine most SDKs and stuff don't know how to just take in a client cert and use it for all of their HTTP operations.
So Ben, what we're saying is we're going to decide what are the list of files per protocol, correct?
Yeah.
So you're saying if we define search to be an expected field for S3, that would confuse clients. Is that what you're saying?
Well, I don't like the idea of just having like generic certs. Like we need to be very specific. Like here's your CA cert, here's your client cert. They have specific file names. You're going to get them in that file, and so you know what you're looking at when you get it, and there's no guesswork. One can imagine a protocol that doesn't use HTTP at all, in which case a certificate might be superfluous, and you would just say, you know what, you're never going to see a certificate with this protocol because it doesn't deal with them. So like each protocol should say like, these are the file names, and these are what you're going to get in those files, and have it be, crystal clear. So there's no possibility of misunderstanding what you're looking at.
I agree. So I was thinking of this more as a directory, which will have two files, which is the CA cert and the client cert.
Client cert will also need a key at least, so you'll have three files.
I mean, I don't see why you'd put those in a subdirectory, but that's just a look and feel thing. So
yeah, that's all it is.
You need for S3 also a config file probably, and because we need to specify somewhere for S3 the bucket name and endpoint, and actually both of them are not.
Well, that's that bucket.json.
Yeah.
Shown.
Oh, I thought that was I thought that was for Google. Sorry. Okay. So that example was all three files for
any
for
provider.
S3 for any provider.
Yeah. For Google, the only difference would be the name of the file. Credentials would be Google config.json, for instance.
So my inclination would be to, rather than try to make everything the same, just have every protocol explicitly specify the list of files you're going to get and what's in them.
I would also expect it, because it would be confusing to have sharing, even if certs is somehow the same, it might not.
I would.
Go.
Sorry, I would, for aesthetic reasons, split the standard ones that all the SDKs expect, like in the AWS case, credentials, that file, from everything that is rather Cozy specific.
But it's all going to be Cozy specific.
No, credentials will not be.
No, to the extent that the Cozy specific stuff can overlap with what people are already expecting, that's great. but like it's still
It's a
cozy
matching.
specific.
So the credential, the format of the file will be designed to meet the SDK, the S3 SDK, because that's the protocol, right? That's by design,
Yes.
right? That's the meaning. The one thing we don't have here, so I think what's missing for S3 is a config file. Could be like if the provider would like to give you a config, which might be relevant
Yeah,
for AWS
actually,
S3.
yeah, I think so. So there is a config file which needs to hold like the default region.
Right, right. It can. I mean, but I think it's all possible configurations for the client SDK that the provider can provide, and of course the application can override, but it's based configuration. And there's something else. So you're saying that the rest will be in a bucket JSON. Is that so? The information that every application needs to read about the bucket name and endpoint will be in that bucket JSON.
Yeah, yeah, and possibly also add the fields from protocol in the bucket API. Possibly, because stuff like version could be useful for clients that support multiple versions. The other thing is that none of these providers seem to provide a way to specify an endpoint. So this has to be
Right.
in our own file. So let me ask
I
you
want
something.
to I wanted to
Go
take
ahead.
a step back if I could. What this looks like is yet another API, right? We've got two APIs so far. We've got the spec to interact with the driver. We've got the Kubernetes API to interact with the end user. This is the third API to interact with the workload. And for the first two, we have very strict definitions of exactly what the API looks like. We're going to have deprecation policies, backward compatibility policies. This one feels like one where we could screw that up if we don't treat it like an API.
I think
So
that's
the
a good point.
question to the group is, how do we formalize this a little bit more so that it becomes a little bit more structured, and it is going to be something that a workload is going to have to depend on. How do we make those guarantees?
Thank you, Saad. That's the concern I've been trying to express, and you made it much more, you stated it much more clearly. I had been proposing that like we enumerate the list of protocols in some sort of like an appendix to the cozy spec that says, you know, this is S3, this is GCS, this is Azure Blobs, you know, and just encode it in the spec, like these are the files you're going to get, this is what's in the files, and be strict about it.
I agree. I think we were all on the same page about that. We just didn't look at it as an API, but I think
I think
we
we're
were all on the
aiming
same page.
to
Yeah.
fit into the ecosystem which is existing more than define our own API here. That's kind of where we are here, and we
Yeah, we're
need to
trying to
acknowledge
understand.
that, right?
Yeah.
That we're not setting
It sounds like
yeah.
there's definitely existing API that you're trying to fit into, but there's potentially going to be kind of some customizations for cozy or like additional pieces of information.
Right.
And so for that reason, what are those differences and that kind of stuff definitely needs to be captured. So if I'm a workload and I say I select S3 or I select GCS through cozy, what is my expectation? What is the contract that I should depend on?
Right. I think that's what we're trying to figure out right now.
Makes sense. And then once we agree to it, how do we want to kind of expose that or share that out, publicize it with folks who will be consuming this?
I think this should be treated like any other API.
So basically like the spec. Okay.
Yeah. Yeah, I think that's the right way. Like you said, deprecation policy, how we evolve this, backward compatibility are all very important. So if we don't treat it like an API.
But to address the concern about existing applications and fitting into an ecosystem that already exists, like that's why we should do things like call the credentials file credentials if it's S3 and format it like an S3 credentials file is formatted today. So that minimal change of existing applications is needed. But like you're not going to get around having to read a bucket.json. Nobody reads that today because it doesn't exist. So like that's just going to be a thing that you have to start doing. in your
I mean, so
workloads.
we did make an assumption last time when we spoke about it. So if there is a workload that we want to port over to Cozy, that we expect that there is no developer to change the application itself. We're saying that is possible in case of brownfield buckets because we know the name of the buckets up front. In that case, there is a, you don't need to know the bucket name up front or the endpoint up front. You could just read the credentials file and applicate from the default path and then just use it and then talk to the backend. So it's still possible for the brownfield use case, the static brownfield use case. And what do you all think is that? I mean, that's the one sort of turnkey porting that we support, where without changing the application, you can simply switch to Cozy if it's brownfield statically provisioned bucket.
Yeah, that should be a goal that we have, so that. But I don't think we compromise on still having everything specified like an API to get that goal.
Right.
I don't think we have to.
Right. We don't have to. Yes. Okay, so coming back to the discussion about what fields needs to be where, so it's clear that we need something like bucket.json. Now, I think these are the three fields that to start with, I think these three fields are absolutely necessary. Now that we've talked about calling an API, we obviously need an API version to it. Should we make this a Kubernetes object? Something that satisfies runtime.object?
I think that might be a good way to handle it. You can
Isn't it something in the bucket access? Like, isn't that what we're binding into the?
Well, hold on.
I think we were talking about the schema. Like, where do you define the schema, and what should it look like? That kind of thing.
But bucket access has a schema, right? In as a CRD.
Yeah, it has the bucket name.
Oh, I see what you're saying. Yeah. Okay.
And we're technically binding the bucket access request, right, into the pod and mounting it.
Could this information be added to status to show state of world, essentially current state, and consumed then? Do we assume a workload has access to their BAR?
No.
We don't, do we?
No, most workloads don't even have a Kubernetes client, so that they rely on us reflecting this into their file system or their environment variables.
Yeah.
But CRDs technically, I mean, we shouldn't have secrets like credentials inside, like the bucket access itself, right? Like the credentials themselves would not be
Correct.
there. So it's like, in any case, it will be some merge of information and not the entire information in one spec or something.
Yeah, I think making it a Kubernetes object would help a lot with that. It will also help us retain a copy of this in etcd for us to know what we've put in there.
But that, I think for that you do have, I mean, the bucket access is the one you're aiming to give the pod, right? It's the information you're sending to the pod. So it seems like you do have that, but it's just that credentials are not going to be part of etcd, right? You're not going to add credentials to another CRD.
So also the other thing is none of the APIs have a field for endpoint as of right now.
You mean in their config files, right? You mean for AWS, for example, configs?
Not just that. In the APIs that we've defined, in the bucket star APIs that we've defined, we don't have. Last I checked, we don't have a field for endpoint. So that's why I was starting a conversation yesterday on our SIG storage Cozy Slack, wondering if we should have an endpoint under the protocol struct.
Well, for protocols that have endpoints as part of the protocol, yeah, and
all accesses over the network, all protocols will have an endpoint.
What does it mean that a protocol will have an endpoint?
I mean, that presumes that you're talking HTTP, which isn't necessarily true, right?
regardless of the scheme, there should be an endpoint.
Yeah,
But
yeah,
shouldn't just the provider
but the
return
content,
that? Isn't
the
it just
contents of the
information
field
returned by the
is,
provider?
Yeah,
Sorry.
yeah, it is. Yeah.
So why is that part of the protocol that is being requested or just responding? You mean it's part of a protocol here, you mean, in the one you're showing now?
Yeah, so it would be a field under protocol, but it wouldn't be set by, it'll always be set by Cozy is kind of how I was thinking of it. Again, it's a discussion I was starting. What do you all think about that?
well, I was also just going to mention that for S3 in particular, I thought you had bucket and endpoint and region. I thought region
Yeah,
was
yeah.
something you needed to know.
Yeah, there's two ways to specify domain, subdomain based or path based. So you could
Okay.
have it as a path param or part of the subdomain.
But I guess what I'm getting at is the interpretation of the endpoint string is going to be protocol specific. Therefore, we
True.
should just treat it as a protocol specific field that tends to occur in for most of the protocols.
Okay, yeah, that's fair. I mean, it's going to be a single URL regardless of the protocol.
That's
And
not necessary. I wouldn't assume that.
okay, fair enough. Fair enough. We checked with Azure and Google Cloud, and obviously S3.
Oh yeah, for
Both
all the
these three.
well-known ones, that is true.
Yeah,
But like,
yeah.
we want to be able to support a future where that's not true, right?
I think the structure we defined for it was that we have like an archetype, like this is the protocol, and then we have a flat, keys for how the protocol would parse the parameters, right? We didn't stack everything. We didn't move everything down below the protocol because we said, okay, this is like a type, and then the protocol itself knows how to use the information there, right?
Yeah, there are some things that are common to all protocols, like the name and version.
So regardless with common, I mean, I'm saying the protocol field is here to have to say what is the type of the rest of the object, right? And then whether if the protocol will suddenly be some kind of InfiniBand, whatever, I don't know, then the arguments will be completely different than an endpoint and a bucket, perhaps, right?
Oh yeah, fair.
So what I'm saying, I don't think you should really push it everything to be under something. I just think it kind of needs to be, the protocol should be like the first switch kind of case between what we're so that,
you want a union-like data structure,
Mm-hmm.
like we have in a lot of Kubernetes objects that could be one of many possible things. You have basically a union data structure where one of the members of the union is filled in, the rest are left blank. Like that's how PVs are.
Yeah. PVs actually have every object type as a field.
Right, but you never fill in more than one.
Right.
So I would see this as the same thing. Like you'd have a giant union, and if you're using the S3 part of the union, you fill in that field, and if you're using the GCS part
so
of
you
the
have like
union,
an S3 object key, and it will be an object, right? We'll have a type S3, and then S3 colon and an object. That's and then all the S3.
No, I think we're talking about the protocol config itself, like information of the protocol itself. To answer Ben, that's how we've already defined it in the API.
But we could mirror that design in bucket.json if we
I think that's
potentially, or we could do it differently.
Any other ideas? How else? Like I was suggesting the endpoint in there. I'm just looking at every option that's available to us so we can understand.
The other way to
what's
do it
possible.
would be to do like the way Kubernetes objects are named, where you have a version and a kind. So you just have a kind, which is the protocol at the top of the structure, and then everything else depends on what that kind is.
I see. Can we not do both? The kind just tells you the name of the protocol, but you still need like version.
Some protocols might be version and others might not be. I mean, that's kind of a stretch, but I don't.
No, I don't think we should mix the version of the protocol with the version of the configuration file structure.
Yeah.
Well, there's that, but there's just like the format of the version string is going to be a protocol specific thing. And the way that you parse that field requires that you've already figured out what the protocol is before you look at the version. Otherwise, your parsing might not work. So like, in a sense, you're already down inside the protocol specific part of the structure by the time you look at the version.
So when you say a union struct, so we already have a structure, already have a definition for the individual protocols. Why don't we just mirror that here, and we can have a config a type, like a Kubernetes bucket config or some type like that. That's common for all the different protocols. So so as far as the type definition is concerned, this protocol field would be just the same as what's defined in the other bucket APIs.
Yeah, I guess I'm thinking that, yeah, if you had one field at the top of the JSON object that was the protocol, and then you could just basically mirror the rest of that subfield of the BAR or the BA into the object, and you don't need the rest of the contents of that. Oh,
Yeah.
and
Yeah,
again, I
only
guess
the one that's
credentials are
relevant.
handled separately, so whatever.
Yeah.
Yeah,
The thing is, I'm saying the BA fields don't seem relevant that much to be here.
I mean, I think we're trying to say just the protocol from the BA.
yeah, just the protocol from the BA.
Okay.
And all of its fields, and I think things like endpoint and version and bucket name and all that stuff should be pushed down into those individual structures, because while it may feel like they're common to everything, I don't think that they are.
Can you repeat that?
The fields like version and bucket and endpoint should be pushed down into the protocol specific fields of the BA.
Oh, I
And
see.
So in the bucket CRD, we have that like protocol, and under the protocol we have that structure, right? That's what you're referring to? Because
yeah,
it's not in
yeah.
the BA, it's like that. So that
Right, it's in the B.
Oh, okay. I'm sorry. Well, yeah.
Yeah, that's okay. It doesn't matter. Okay, so I'm gonna write the JSON right now, so we're all clear on what we're talking about. So I think, Ben, what you're saying is
The first thing is protocol, which is S3.
yeah, protocol, and then
then
the fields from the protocol here.
right, and that would include the endpoint and the version and the bucket and maybe the region, whatever.
Yeah,
but if you look at the bucket, you have that structure, but just not exactly the same as you're writing.
yeah. You mean like S3:// bucket name?
No. So in the bucket, in the cap, right? We have a protocol sub-object for the spec of the bucket, which has a name, a version, and then 3 optional keys: S3, Azure Blob, or GS.
Yeah. So we're saying the contents, the subfields of those optional keys would be first level fields in this object.
Yeah.
So
to me, it sounds weird that we will have 2 structures that represent the same thing but look different. If that's a good structure for the applications, and so why are we defining these differently?
So originally I was thinking of it this way. So like bucket and endpoint would be common, name and version would be under S. No, name and version would also be common. And then S3
but why?
specific
Why are you looking for common? I mean, making it common. We didn't do it for the bucket API. Why suddenly make common fields? What's
name
the
and
purpose?
version are common.
Yeah, name and version are the only ones you have common also in the bucket.
So this was my question yesterday that I was asking Slack too. Should we push this information like endpoint under this protocol specific fields?
Yeah,
I think everything should be pushed under there. I would even push the name and the version under there.
Maybe even version. Yeah.
I mean, we expect every provider to have a version. So like we don't have to know if it's
Still,
S3 specific or GCS specific.
but
It's just a string.
you're making, yeah, you can leave it on optional, right? That's another way of making everything, but then you're getting a merged kind of full of
the problem with leaving it at the higher level is you can't validate it. It's strictly right.
It will become optional. That will have to be optional then.
If you put it
It's
under
already
S3,
optional, yeah.
you can validate and say it must be one of these known values for that are S3 specific, and then if it's not one of those three or one of those supported values, you can chuck it out. If you leave it at the higher layer, validation gets a lot trickier.
So
because S3 versions might be like S3 v2 and S3 v4 and S3 v9 or whatever, but like GCS might have a totally different versioning scheme, and they might want to validate their version with a different algorithm. So like it just feels that it's specific to
clear.
protocol.
So yeah, version is kind of a confusing field actually, because how we were thinking of it, and a few others have also, we also had this same question here. Sometimes we don't, the version field, if it is not specified by the user, Cozy would fill it for you, because the provisioner, we assume, chooses one of the protocols as the versions as the default, like S3, V4, and then fills it.
Wait,
that.
version was not meant to be signature version. That's completely different. That's not the use case. Signature version is there for V4, V2, things like that, but not version was meant to be the date kind of versioning scheme that you can set as a client that you'd like to have to match with a server. And AWS has it for SDK version, I think.
Oh no! So it doesn't matter. The date version does not matter if you're following a standard. So S3 V4 is a standard. So
no, regardless of signatures, this is regarding the entire S3 protocol set.
Entire AWS. So AWS allows you to do that.
It's per API. In AWS per service, they have a date where they deploy.
For S3, it doesn't matter, because S3 V4 is a standard. It doesn't matter which version of the SDK, it's still S3 V4.
But you're just talking about how do I sign the request? What about which requests are supported?
Again, so S3 V4 standard defines both how to sign as well as what are the different APIs.
No,
it does.
No, it doesn't. So it doesn't. So I'll show you again. I sent it before, but I'll send it.
Okay.
It's called a protocol version for or SDK version for AWS.
I see.
I'll send it. I'll send you a link.
We should just look at the SC specification. There's the API reference. Yeah. So you're saying regardless of which version it is, all of these calls are supported, like regardless of the signature version?
Yeah, I just sent you. Oh, did you? So look at locking. Look for the locking API versions. That will give you the.
Okay, locking API versions. API version numbers to keep track of API compatibility. Okay, again, this is not for S3.
Yes, of course it is.
Current API version for S3 is that we recommend locking the API version for a service if you rely on it for production code. This can isolate the applications. Okay, whatever. To lock the API. Go ahead.
Some SDKs might need this field, but there are ones that don't.
Right. True. I mean, that's the point. I think that wasn't supposed to be the signature versions, which is also very specific to S3.
The signature version, I agree with that. We got to include the signature version. It should probably be called signature version instead of version.
It's already there, right?
To avoid confusion. Well, in this PowerPoint or whatever, the slide.
No, I mean the cap. I'm just looking at the cap.
Google Slides.
Just look at the cap. If you see the structure of protocol in the cap, it's already.
But it already has the signature.
But this other version field, I'm kind of nervous about it. If there are SDKs that depend on it, but they're implementations that don't have it, like what will happen?
It would be, sorry, you're saying SDKs that depend on it and implementations don't have it,
Right,
huh?
he's talking about a version string that's not the signature version, it's some other version
Yeah,
based
yeah.
on a date. And it's like, if I write my own S3 implementation, what do I supply for the date?
We should, so there's two things you can expect. We can expect the workload to understand a default version, just choose a default version.
No, it should
Or,
be compiled into the workload usually, or configured into the workload somewhere, because
yeah.
it was taken as an assumption when you when you design the workload. That's the point, right?
Mm-hmm.
That's about locking the API.
Or we could say when we start the provisioner, we do a get info call. It's supposed to provide us a default version. That can't be empty, let's say. I'm just throwing out options here.
In any case, I would probably clarify it by renaming it to API version, because that's S3, and put it under S3. And
I was also thinking that.
Yeah.
Wait, actually, this confuses things actually. So if you're going to do, okay, so this should go under S3 then.
Yes, of course, yeah. So it's only clear about what it means for S3.
Okay, I think that's fine.
And
so,
bucket
and
and
else is needed?
Bucket and endpoint. So
Also,
we have bucket name under S3 in the cap as well. I think that makes sense as well, and endpoint as well. So I think, yeah, and just like Google did not, in Google we did not define endpoint, but for S3 we did, right? That was the kind of.
Yeah, I think we didn't need it last we checked, but that might change.
So S3 probably can, and so in one way or another you can separate between AWS and S3, but it maybe might feel artificial to some, but for me it makes more sense to separate between the ones that are services like GS, AWS, and Azure Blob versus the ones who will have to have an endpoint and things which otherwise they don't work. And in this case, S3 at the endpoint under S3 with AWS doesn't have to provide an endpoint, actually. Only has to provide a region. So
yeah, region needs to be in there. Well, actually, again, it could be some other implementation of S3 standard, like Ceph or Mini or.
Yeah, and that's what I'm saying. So S3 compatibles will have to have an endpoint, but will not have to have a region. And AWS will have to have a region, but has an optional endpoint, right? So I think it might make sense in some ways to separate between what is AWS service that you'd like to have here, like Google, and S3. But I'm not sure if you kind of feel the same.
I think region is, all the implementations of S3 support region, and they also, like all the SDKs of S3 support giving an empty region, which assumes the default region. Endpoint, again, even with S3 SDK, endpoint is optional. Because if you're using GovCloud, for instance, you have to provide the endpoint. So I think it's okay to have all of them under one protocol rather than have AWS specific versus.
Yeah. As I said, it's a semantic difference. For AWS, the region is mandatory. Actually, it is mandatory. I think if you don't, it has to be provided in your config file if it's not in your SDK. So it has
Can you guys hear me?
No, yeah.
Okay, I'm sorry. I lost power for like, I don't know, 3 or 4 minutes. Hurricane Zeta.
Where are you, Ben?
North Carolina.
Okay.
It's just the remnants are blowing through here and knocking out power. So I'm sorry, I missed what was going on. Continue.
Okay, so
region and endpoint, but yeah,
we moved region endpoint down into the specific protocol
and bucket,
and bucket as well, right? Now we were talking about endpoint and region, saying that endpoint is needed only if it's non S3, and region is needed only if it's S3. In the sense, AWS S3. So we were saying AWS S3 versus S3 compatible services. So we're saying endpoint is only needed if it's a AWS S3 compatible service, and region is needed only if it is a S3, AWS S3 itself. However, both of the statements are not true. The reason we were bringing the argument up was to see if we needed to create two different structures here, like S3 and S3 compatible, but I think that's not needed.
Yeah, I would hope that we could have one S3 structure that covers all the cases.
Yeah, and it's okay to have optional fields here.
Well, it's okay in principle, but we have to think through, you know, what does a client do if the field is populated? What does the client do if it's not populated? And make sure that you don't have a situation where
Right.
you have incompatibilities that are unresolvable.
Right.
Because I want to be able to write a client that will work with any S3 provider, no matter, you know, how crazy it is, as long as it conforms to S3. And then if someone wants to write something that's not compatible with them all because it wants to take advantage of some special sauce, they're welcome to do that.
Right. So
that's
we
a good
can
goal.
always, yeah. So so anyways, do we have a name for the type or the kind?
It's I think, isn't it? It's defined in bucket. I see now. It's like it's inside. No, I mean it's like bucket.spec.protocol. That's where you define it now.
Right. This is.
Should it be any like a top level of its own copied from the bucket? Is there any use for it?
Is there precedent for dumping Kubernetes flavored YAML into pods already?
Service
I don't
account
think so.
kubeconfig.
Because I was going to say, like,
Isn't it downward API? I mean, isn't it that?
I didn't think the downward
Yeah.
API ever gave you an actual blob of YAML that looked like this.
So going back to what Saad was saying, and I kind of agree with this, because the protocol itself is basically going to be an API. Whatever we define here is going to be an API contract for all the different providers that implement a particular protocol. We should treat this structure like it's just another API.
But we are a
Like,
marketplace between providers and applications here. I mean, if we define that this is a good structure for the provider to provide the information through, isn't it? I mean, should we recompile it differently now? I mean, I'm just trying to find what are we trying to do by creating another API which replicates the entire structure then?
the only reason is in order to manage the evolution, deal with deprecation and backward compatibility.
Yes,
Go ahead.
I agree with all that.
But what does it mean that you'll have providers providing different structures than the applications, and then you'll have some conversions in Cozy doing between the older versions and the new versions for the applications that with this version and providers in this version?
No, let's say for the same API version of S3 and the same signature version of S3, we might end up having new fields added.
Okay.
So this config file should evolve independent of the fields here.
But it should evolve also in the bucket CRD, right? Otherwise,
Absolutely.
how the providers can return it?
Absolutely, yes. So the workload, the contract between the workload and Cozy itself is not directly tied to the bucket. It is, in a sense, it's indirectly tied, but not directly. What I mean by that is there should be a version here which should exist as a contract between the workload and Cozy. Just that. I know what you're saying. You're saying that this version already exists in the bucket, so
bucket
it should
request, bucket access request. I mean, that's all. I mean, the requests are the ones identifying the kind of contract, right?
Okay. Is there a scenario where that can evolve independent of what's in the pod?
Only
So
if it's
say
compatible,
you're
right? I mean, if you evolve it and add fields, then yes, you can, right? But if you remove a field, you'll have to bump
the
a
version.
version or something.
Right. So take this example of porting between two cloud providers. I'm moving from GCS or to AWS, and let's say the admin creates buckets, and in GCS first, the old infrastructure, and they use this definition of let's say both support S3, a hypothetical scenario, and let's say
GCS does
there are
support
5 fields.
S3.
There you go.
Yeah.
Okay, so you have these 5 fields, and then now I move to AWS, and on AWS, it's an older version of the protocol. So the application, which is expecting 5 fields to be there, would only find 4, let's say, and that would be an issue.
So if you add new fields which are required, then of course, then the protocol that like the previous provider of AWS is not compatible. But if you add an optional field, then you are compatible, right? It's if you
My
add a
question,
required field, and so all your previous provisioners, like the AWS one that you mentioned that is providing just 4 fields, is not compatible with Cozy now because we broke in that bind between the provider first, and we have to.
I'm saying it
update
was a previous version of Cozy itself. I'm saying.
Well, but the new provider is not, I mean, the AWS provider is not compatible now. We have to update that and return the new required field for the bucket to be valid. I mean, otherwise, how would we allocate buckets from AWS this way? We have a new required field in this structure.
Yeah, I think I get where Guy's coming from. Basically, the bucket access today contains, the bucket access object contains all the information that a workload should need in order to connect to that workload or connect to that bucket. But if we have yet another object, what would the difference between that bucket access object and that new object be? And if the new object evolves or the bucket access evolves, is there ever a case that they would evolve in 2 different ways? And it sounds like probably not, because the purpose of the bucket access object is to be this intermediate API.
It's actually spread. Yeah, but I'm saying that, but I think it's a little bit spread out, and I'm not sure how that would how that's convenient, because there's multiple things here. There's the protocol comes from the bucket. In the bucket access, there's a reference to the secret where we need to pull in the credentials, right? So there's either way that this API will not be, even if you define it as a new CRD, right? It will not be any more complete. It might be more concise, but it will be still some copying.
I think that if there were any evolution of this object with these fields, like say, for example, I don't know, wanted to change the spelling of one of the words for some reason, like you'd have to, in order for clients and servers to, or clients and providers to both be compatible, like something would have to do translation at some point, right? Like if let's say you misspelled the word bucket, and so we had to add a new field with the correct spelling of bucket. Like, well, for backwards compatibility reasons, you have to continue supplying the old bad spelling and the new spelling, and you have to copy the value over, and then you have a deprecation period for the old one, and eventually it goes away. But like there's some period of time where like something is providing a translation between old providers and new clients, or new providers and old clients.
All right, but that does it need to be a standalone new object, or can it be the existing API machinery for the existing bucket access object?
I suspect that the latter, that it could be the same thing. It's just we have to be very careful about any evolution of these objects, because they're subject to all the backwards compatibility rules.
Right, and we need to make sure that to realize that anything that we throw into bucket access would end up being surfaced here and would impact actual workloads directly.
Yeah. But that doesn't sound scary. It seems okay.
Yeah.
We're just gonna have
One
to be
last
super,
question.
super careful about the exact details of for each protocol.
One
Question is,
last question.
what will we say? Will we say that this structure comes? I mean, because I understand where you came from, Sid. You wanted to have a CRD with a spec that I can always inspect and understand what I expect to see in that file, right, or something like in that JSON.
That's exactly, yeah.
But now, like when I'm saying this is the same, maybe even if it's the same, we need to share it in the kind of Go types system, but eventually still create another CRD just to represent this API. I'm not sure if that's a good practice or not, but
No, do we need it?
But then how do you represent what's going to be in this JSON if it's more than just this field?
No, does it
Like
have to
if
be a
it's one from,
CRD? It can be a structure, but does it have to be a CRD?
yeah, it doesn't have to be a CRD. Just it will be, by being a CRD, you can explore it right through the API and things like that. I'm not sure if it's very important, but how do you can just put it in documentation and generate it or something. But then we probably want this to be somehow tied to these structures, saying this protocol comes from the bucket, and this if there's something else that we need to bring, like the bucket. Well, actually, we said that the bucket name is inside already for the protocol, so maybe that's the entire information we need, just the protocol information from the bucket and the credentials, like another information for credentials and configuration maybe, and that's it. And then we're saying it's a collection of these. Well, maybe configuration, for example, configuration will probably be below the protocol, like we just said, right? That's the configuration somehow. But for S3, we need to generate a config file in their format for the SDK.
We won't generate it. We'll expect the provisioner to give it to us.
So we have to find a way to wrap up this meeting and
yeah, that's true. All right, we can continue this. I just check the time. Yeah, so we can continue this on Monday. I think this is a good discussion. I'll try to compile this down into just the points that we decided on, and we'll go from there.
Sounds
Thank
good.
you, everyone.
Thanks. Bye-bye.
Bye.